Hello, in this video I will introduce the WISP-3. I will also guide you on how to operate the WISP-3 and upload data to WISP Web for further analysis. WISP-3 is an easy to operate handheld hyperspectral spectrometer to assess surface water quality. The instrument derives water quality parameters from the inherent color of the surface water. Why use the WISP-3? Scientists use the WISP-3 to collect reference measurements for interpretation of optical satellite imagery. The WISP-3 is therefore a highly valuable complement to integrated optical monitoring of the environment. Because of its speed and flexibility of use, combined with smooth upload and inspection of data on WISP Web, WISP-3 enables day-to-day decision support for water managers, aquaculture farmers, and ecologists. Trends in algal blooms can be followed and preventive action to protect water safety can be taken in time. The WISP-3 analysis of water color is delivered at low operational cost as compared to laboratory measurements. The number of environmental observations can be drastically increased by including the WISP-3 in monitoring programs. Benefits of using the WISP-3 according to the testimony of our users: on-the-spot results, easy to understand, adaptability to local algorithm, portability, diverse application, narrow field of view, long battery life, and no subscription fee to the WISP Web. How does the WISP-3 work? At the push of a button, the WISP-3 will store and analyze a set of 3 light measurements. As you can see on this slide, the sensor on top, labeled as sky irradiance, measures the light field that is incident on the water surface. The 2 channels at the front are used to determine the fraction of light that interacted with the substances in the water. One of the sensors, labeled as water radiance, points downward at 42-degree angle to capture all light leaving the water as well as sky light reflected at the water surface. The sensor that looks up at 42-degree angle, labeled as sky radiance, collects the skylight separately so that its influence on observed water color can be determined. Then, remote sensing reflectance, or RRS, is immediately calculated by combining the information from the 3 measurements. The WISP-3 submits the reflectance to built-in algorithms, matching it with concentrations of phytoplankton biomass as chlorophyll A, phycocyanin, and water transparency on its display. In doing so, the instrument brings decades of optical water quality research immediately within reach. The measurement protocol consists of 3 topics: planning the fieldwork, preparing and operating the WISP-3. Planning the fieldwork. We recommend measuring when the sun elevation is at least 30 degrees above the horizon. You can check online at what time the solar elevation angle stays above 30 degrees. Before you leave for a field measurement, first make sure the WISP-3 has sufficient battery power. This can be checked as illustrated here. Power on the WISP-3. Press Cancel in the main menu to enter the spectrometer menu. Navigate up and down using the triangle-shaped buttons. Do that until System Tools is highlighted and press the checkmark button to select or enter the System Tools setting. Scroll down until you locate the battery info and click the checkmark button to view the battery level and remaining charge time. To return to the measurement menu, press Cancel and press Home button. To charge the WISP-3 battery, connect the AC adapter to the power connector inside the bottom panel. Alternatively, a USB cable can be used to charge, but this will take longer. To create a custom file name for your sample station, turn the WISP-3 on, press Configure, then select Base File Name. Navigate through the alphabet with the Control button, left, right, up, down, and accept characters with the checkmark button. To accept the name, navigate to Done and press X. All subsequent measurements will now be stored under this base name. For example, station 000, station 001, station 002, and so on. Please note, the base file name is lost when the WISP-3 is turned off. The WISP-3 system time should be kept on Coordinated Universal Time or UTC so that measurement, location, and timestamp can be used with algorithms that require information on the sun position. Look around for a suitable measurement location away from trees or high structures that block light from reaching the water and or the WISP-3. Avoid areas with floating vegetation, leaves, garbage, bottom visibility, and shadow cast from the boats or jetty you are on. Scattered clouds may hamper accuracy because the measurement from sky radiance sensor may not represent the same light as reflected on the water surface and measured by the water radiance sensor. If clouds are moving in and out of view, try waiting a while for homogeneously open or closed cloud cover. Taking additional measurement is also recommended under doubtful conditions. Waves can also interfere with accuracy, although this is normally sufficiently reduced by measuring in the correct direction relative to the sun. The WISP-3 averages 5 measurements, which further reduces the effect of darker and lighter wave slopes. Clear and completely overcast skies provide the best measurement condition. Boats, jetties, rafts, and bridges without superstructure can provide ideal locations. To take your first WISP-3 measurement, start by removing the protective cover. Then turn the WISP-3 on and keep it horizontally in front of you. It's very important to operate the WISP-3 at the intended horizontal and vertical angles. The bubble level will help you to keep the instrument level during measurement. Keep the WISP-3 slightly above your head to make sure you don't block the field of view of the sky irradiance sensor. Equally important is the angle toward the sun and possible shadows. Seen from the right side plot, the WISP-3 should be positioned near 135 degrees away from the sun, or, in other words, at 45 degrees away from where shadows cast by the sun reach. There are two suitable angles, measured either clockwise or anti-clockwise from the sun, as illustrated in the right side. Reflections of the sun and the sky on the water surface are kept to a minimum when measuring at this angle. The correct position should be kept during the measurement until the display indicates the measurement is finished. If the sky is fully overcast and shadows are not visible, the angle is less critical, but measuring towards the position of the sun is still not advised. Now we are ready to take our first measurement. From the main menu, simply press Measure or the hashtag button to record a measurement. The display will show adapting to light, followed by the percentage completion of the current measurement. Keep the WISP-3 steady until the screen blinks several times and estimates of chlorophyll A, phycocyanin, light attenuation, and total suspended matter are displayed. The measurement is automatically saved. To view the reflectance spectrum after a measurement, press Home and select the O button. WISP-3 saves its measurement on an SD card. To retrieve the data, turn the WISP-3 off, open the bottom panel, press on the SD card to release it, and place it in a suitable reader in your computer or a suitable external card reader. In the SD card folder, you will find a folder called WISP. In the folder WISP, you will find a folder for each time you create a new base file name. The names include the date of the measurements and the base file name you gave it. Each folder contains two types of .txt files, one containing the spectral data of your measurements and one with the derived parameters. Both file names include the date and the time of measurement, the base file name, and end with spec and conc for spectrum and concentration respectively. If you took several measurements under the same base file name, you could tell them apart by their time stamps. As a WISP-3 user, you have access to WISP Web. WISP Web is a facility where users of the WISP-3 can store and analyze their data. Their measurements will be screened for inaccuracies and subjected to optical models to fine-tune the observations that the WISP-3 already provided in the field. Go to wispweb.waterinsight.nl, fill out your username and password, and click Login. With the purchase of your WISP-3, you have received a username and password for WISP Web for unlimited access. After login, you will find a quick uploader on the left. Here you can upload measurement files to the WISP Web system. Now click the Browse button, find the file you want to upload by clicking on the folder WISP. Double-click on the .txt file you want to upload to WISP Web, or if you have multiple measurements, drag and drop all the .txt files. After you have uploaded your spectral files, they must be approved and have metadata added before they become visible in the rest of the WISP Web application. The gray box at the top functions as an autofill template for the other measurements. Anything you enter here will be automatically copied to the other pending measurements below. Some of the input boxes, such as region and station, will have autocomplete functionality. That means if you have entered a region name before, it can now be selected quickly from the input box. WISP Web will also attempt to fill in station coordinates for you if you have entered coordinates for that specific station before. It's also possible to add specific information to a single measurement. In that case, simply use the input fields that correspond with that measurement. Doing so will again override any of the defaults selected using the template. Clicking the Approve and Save button saves the measurement and makes it available in the rest of the WISP Web. When you enter WISP Web, the search page is always the first thing you see. On the search page, measurements that you have uploaded are shown as default. If you are enrolled in any groups or projects, you can also view measurements that others have shared with this group. The search filters let you specify subsets of measurements, for example, only measurements within a certain date range, or only those taken at a specific station. The advanced search options let you filter by geographic area, parameter values, or by weather conditions. By clicking on details of any measurement in the graph column, you will see a page containing the measurement detail of that single measurement. On the upper left, you will find the derived water quality parameters for this measurement. If you have filled out the station coordinate in decimal degrees, you will find a map on the bottom of the page showing the location of the measurement. You can zoom in and out on the map by scrolling with the mouse or by using the plus and minus buttons. The metadata tab shows additional information about this measurement, such as the exact date and time, region, station, WISP ID, and the algorithm used in the calculation. In the middle of the screen, you will find two graphs. The upper graph shows the derived reflectance just below the water surface. The lower graph presents the calibrated measurements of the 3 channels within the WISP-3. All spectral data are presented over the 400 to 800 nanometer range. In order to view the reflectance spectrum of multiple measurements in one graph, go back to the measurement list and check the boxes of several measurements in the first graph column and click Compare Search Results. We can filter data using the following features: location metadata, that is region and station. We can use date and time of the measurement. And we can also use derived water quality parameters such as chlorophyll A, total suspended matter or TSM, or diffuse downwelling attenuation coefficient or KD. To download the derived water quality parameters of one or several measurements in Excel format, click Download Data and select Parameters from the pull-down menu. The file will contain columns for region, station, date and time, chlorophyll, TSM, CPC, and KD. There's also an option to download the calibrated spectral data. To do so, select Parameters and Spectra in CSV. A similar spreadsheet file will be created, now containing the data in rows, plus 4 extra rows for sky irradiance, water radiance, sky radiance, and the subsurface reflectance R0-, all between the wavelength range of 400 to 800 nanometer region. The WISP-3 is sent from Water Insight fully calibrated. Calibration files from the 3 channels are saved onto the memory card of your WISP-3 and are used in the built-in algorithms and WISP Web. Once a year, the WISP-3 needs to be recalibrated at Water Insight. Opening the WISP-3 reduces the calibration accuracy and requires recalibration. The WISP-3 is equipped with a shock indicator under the bottom panel. If the shock indicator is red, calibration and alignment of the spectrometers in the WISP-3 need to be checked at Water Insight. Thank you for watching. Do you have any questions? Please don't hesitate to contact us at info@waterinsight.nl.